I'm the Scrum Master for Team 9, and joining me today is Vanessa Soares, our team lead, Ian Eichhorn, our developer, and Daniel Champagne, our researcher and tester. And our project is blockchain visualization, and our sponsor is Bradford Doyle with NUIC, Naval Undersea Warfare Center. And today I'm going to tell you about blockchains. So the purpose of our project was to inform the general public about use cases of blockchains and how they can be used to prevent data loss and tampering. And the way we did this was through an interactive web application that implements a blockchain backend. And this web application is what we'll be demonstrating at the end of our presentation. And we also included an extensive research guide that contains research about blockchains and other blockchain-related technology. So the first thing that comes to most people's mind when I say the word blockchain is Bitcoin. And Bitcoin is pretty popular, but I want to make a key difference right here. So if blockchain is that of an operating system, Bitcoin is that of an application or a program running on an operating system. So Bitcoin is just one financial use case of blockchain technologies that allow you to have a currency that is tamper resistant, which is pretty unique and powerful. And some other use cases that are prevalent in blockchain technologies deal with sectors such as cybersecurity. And so in cybersecurity, if you can imagine you have a client who might have dynamic data that needs to retain its integrity, you can use blockchains to ensure that that data's integrity remains secure. And you can trust that data's integrity via blockchain's inherent prevention of data loss and tampering. So in the healthcare sector, you can have a blockchain handle insurance claims, maybe. And these insurance claims could be handled in an automated way, and the blockchain could be used to store all your data. And in government, you can have use cases such as virtual voting. You can imagine having an election where your votes are tamper resistant and you can trust that every single vote is authenticated. That is incredibly useful. And with this technology, you can have things like that. And also record management. So let's say, for example, birth certificates. You can store birth certificates on a blockchain about, for example, Massachusetts. And Massachusetts could have a permanent ledger of birth certificates. And these are things that won't change. So a use case for UMass Dartmouth might include storing a student's name, age, and ID on a ledger somewhere. And this is in case, say somebody wanted to put a ransomware on a UMass D server and corrupt all student information on a database. That would be really bad, and the school would have to pay a lot of money to alleviate that problem. With blockchains, that problem doesn't exist because the ledger of information is distributed across a network of computers, and it's in a peer-to-peer system. So you don't have to trust a third party. So now let's talk a little bit about what a blockchain actually is. So a blockchain is a digital and decentralized ledger, and it is upheld by a distributed network of nodes. And a node is just a computer that is connected to the blockchain. And these nodes all perform a consensus algorithm. And that term is a little vague, and it differs per blockchain. But this consensus algorithm, each computer is going to take the block that's being added, and they're going to perform some operations that ensure that that block is valid and all the information being added to that blockchain is true and doesn't tamper with any of the information that has previously been on that blockchain. So what exactly does a blockchain look like? Well, quite simply, a blockchain is a chain of blocks. I know, crazy. And within each block, you're going to have multiple different data fields. So one such data field might be the block number, and this is going to be the number, the block that is referenced. So say block number 774, that'd be the 774th block on the chain. Other important fields would be the data stored by the user. So this data stored by the user can range anywhere from a voter's tally to a candidate to a complex business transaction between businesses. And also within a block, you're going to have a hash that is generated at the moment that block is added to the chain. And this hash can kind of be viewed as the link between the blocks that link them together. So if you start with the most recent block, you can follow the lineage of the blockchain via the previous hash to the, which will link you to the hash of the block before it. You can follow that all the way back to the first block. So in this way, everything is recorded. So in the past, a lot of our data was stored in centralized locations. And in this representation right here, the dots are going to be nodes. And in the centralized picture, you can see that all nodes kind of is getting its functionality from a single point. Now this is bad because that gives you a single point of failure. So what we've done recently is that we've kind of been moving to a more decentralized structure for many data servers and applications. And decentralized is pretty good. However, your nodes are still dependent on a central authority. And if one, say a data server goes down in a certain region, that certain region will lose power, but the rest of the system remains unaffected. So that's a bit better than centralized, but it's still not good enough. So we're moving into a distributed technology environment, and that's what blockchain is. And so distributed, each node on the network will add functionality to that network. And if one node goes down on the network, the rest of the other nodes are unaffected. And that's really useful, and that's one of the reasons why blockchain is good for tamper prevention. And so how can we use this distributed network for preventing the loss of data and for ensuring our data is tamper resistant? So we do this, so the reason for this is, there is no central authority, and there's no singular third party that we have to give our trusts to. So this distributed network on a blockchain allows for trusted interactions between users who don't have to trust each other. And it's a peer-to-peer network. And on top of that, every transaction and every interaction that happens on the blockchain is recorded, and it's public for all nodes on the blockchain to see. So if anybody tries to do any funny business or anything, every single node is going to be like, wait a minute, this doesn't match up with what we're all saying. And in that way, we have tamper resistance. And also on the distributed network, if somebody wanted to change something on the blockchain, to change a record, they would have to successfully change a majority of the nodes on that network. And that would take an immense amount of computing power, and it's not theoretically impossible, but it's really tough. It'd be really, really tough to do in a real world situation. So how can we use this tamper-proof and data loss resistant technology to make applications? So there's these tools out there, and this tool is called smart contracts. And smart contracts are tools that allow developers to create applications on the blockchain. And if you remember from an earlier slide of the chain of blocks, you have that data stored by user field. A smart contract will set guidelines for how the data being stored by that user is added and appended to the blockchain. So a smart contract can set guidelines from anywhere as simple as taking a voter's tally and adding it to the candidate on which they're voting for, or as complex as taking a network of vending machines and having the vending machines tally their own inventory, call for a restock of their own inventory, and pay for that restocking of their own inventory, all on their own, all in a distributed manner. And so that is really cool, and not all blockchains support smart contract development. So one blockchain that has really great smart contract development is Ethereum, and they have their own smart contract coding language called Solidity. And so in our project, that's what we opted to use. So that's the blockchain that our project runs on, and that's the code that we've created our smart contract on. And if an application has a smart contract that interacts with the blockchain, we call that a DApp, or a decentralized application. So if you ever see that online, it just means it's an application that uses smart contracts to interact with blockchain backends.
So for our development, we used a couple different coding languages. For the front end, we used HTML and CSS and JavaScript. The back end, we have web3.js. The middleman is web3.js and node.js. They communicate with the back end, which is our Geth and Solidity nodes. Our very back end is actually our Solidity contract in JSON. Our web app hosting, we hosted it on a Linux server running light TPD, and another Go in between, so you don't have to run an entire Geth node on your machine. We use a browser extension called MetaMask. It's available for all the major browsers except Internet Explorer, but what can you do about that? Right. So our Scrum development process, we met 3 times a week. We had Scrum reports every 2 weeks, and usually our Scrum sprints were about a week, 2 weeks. We communicated on Slack, and we stored files on Google Drive. We used GitHub for version control as well. So this is the basic idea of what our application will do with data when the user enters it. So it'll start at the web application, which the web application will send the contract to MetaMask. MetaMask is the go-between between the Geth node and the website itself. From there, it sends it to the blockchain, which looks at a specific address on it to find our smart contract. Every node in the network then executes that code and computes all the hashes and does all that other stuff that you need to be able to make a block on the blockchain itself. So on the next slide. So here's just another view of what our data actually does. Like I said, it starts with a web app, goes to MetaMask, and then ends up at the blockchain. It's there forever. And from the blockchain, if you want to get that data back, all it does is just send it back over MetaMask, and MetaMask displays it on your web page. From here, we have a couple product features that we wanted to put into our product. We can add a block on our website. We can search for any block by age, name, or ID. We can view the blockchain in a couple different ways, which you'll see in a minute. We have a statistics page, so you can see every node on your network all at once and see the status of your network. We have frequently asked questions about blockchain and other technologies based on blockchain. We also have our guide, which our client asks us to write, and we have a tutorial as well. So from here, we're going to go over to our demonstration. I'll put this mic down. It's backwards. There we go. All right, so here's a homepage of our website. You can see here I have MetaMask installed, and it's currently connected to a local node on my computer. So we can see what that looks like right here by clicking on Ledger View. Once it loads, we can see there's a list of names with IDs, ages, what block number they are, and what block number they are in the actual blockchain. So you can imagine this is the UMass system for keeping track of students on the campus. So they have their ID, their age, you can't lose their identity. So what happens, so this is my Geth node I'm running, what happens if it goes down or ransomware hits my computer? And it goes like that, and now it's down. Refresh the page, there's nothing there anymore. Thankfully, we have another node running on our network that we can just switch to very simply for MetaMask. Click on that. Once it connects, it should load up all the blocks. There we go. Everything's back to how it was before. No loss of data. So from here, we're going to show you how to add a block. Would anyone like to be in the blockchain? All right, Jason. I'll put you, what's your last name?
Bechtold. Bechdolld.
All right. And you're how old?
I am 20 years old.
All right. And this is your made-up ID? So when you hit submit, MetaMask pops up and asks if you want to confirm the transaction. We hit submit there. A little notification pops up saying that it's currently mining. Mining takes a little bit of time. every block needs to be hashed out. All the computations need to take place for the actual Solidity contract. And sometimes it can take upwards of 5 minutes. So for now, like even on our network isn't very powerful, but there's not a lot of competition, so it's easier to mine blocks. So while that's doing that, I'm going to show you some other features of our application. So we'll go to search, we'll type my name in. If we search it, you can see that it'll pop up at the bottom at some point. There we go. You can see that my name, ID, and age are there, as well as if there was another person named Ian Eichhorn on your network, you could have them both. They would just have different IDs or different ages, or something would be different about it. If you click see more, we can see different aspects of a developer's view of a blockchain. For example, you can see how hard it is to mine the block with difficulty, what the hash of the extra data is, how much gas it actually costs to mine the block, the hash of the block itself, what miner mined it, what number on the blockchain it is, how big it is, when it was mined, and how difficult the blockchain was at that point in time. So we're done with that. We can search by age as well, so I can put 26 in. Oh, I did just put ID, my bad. Yep, and if you put something in that's not on the blockchain, it'll tell you. So if you put 26 in for age, it'll pop up in just 2 seconds. There we go, you can see that there's 3 people with age of 26. And then if we put the ID in, hopefully it's mine by now, of the person that we just did. See, now Jason's on the blockchain, and his ID, name, and age are there. So let's take another view of the blockchain, an advanced view. This is more of a visualization of what the blockchain actually looks like. You can see that everyone has their own block, and it's just an easier way to see all your data. And you can see it, you can also click it, see more on this page and get all the same advanced stats as earlier. Let's go to blockchain statistics now. We can see we only have 1 node running currently because I took the other one down while we were doing the demonstration. We have how many blocks are currently on the blockchain, how many seconds ago that the last block was mined, how long it usually takes to mine a block, how powerful the network is, that's what the hash rate is, and how difficult the entire network was to mine. We can see here that as you add more blocks to the blockchain, it gets harder and harder to add blocks, just because it's harder to compute the hashes each time. Because you need X amount of leading zeros to compute each block hash, and you get less and less numbers that match those criteria as time goes on. All right, so that's good for functionality. We're gonna take a look at our guide now that we wrote. It's just a PDF on the website, but you can click on specific table of contents to go right to them. So we have chapter 1, just what are decentralized consensus systems. We have concepts and definitions. We have an entire chapter on blockchain. And there's also things that are kind of like blockchain, but not really, like Hashgraph, Tangle, Hyperledger, and I'll zoom in, my bad, Hyperledger and Corda. We have a chapter on comparing each of those technologies together. We have our FAQs, which are also on the website. And then we have tutorials about how to set this application up yourself. So setting up your own get node, actually setting up the website, the statistics page, all that. And then we have chapter 11, which has our troubleshooting the problems that we ran into during development that you might run into as well, such as the version changed on Geth once, and we actually couldn't use what we were using before to put contracts on it, and it was very difficult to figure out what was actually wrong. The technology is so new, so there's so many new things happening. Then we have appendices, so if you want to learn more about the technical details of like Porta, we have a link to the website there. So we have FAQs here, just about the blockchain. If you want to ask us a specific question that's not on this page, you can click on that little question mark, type in your question, and it'll email us your question. In the same vein, if you have a bug, if you find a bug on the website, you can click on report a bug, and it'll also email us that question as well. So let's go to, we have entire sections on blockchain alternatives on our website, like Hashgraph, and the comparison from the guide on the website itself as well. And finally, we have a tutorial, so it'll walk you through the website. So when you click add a block, it'll bring you to the add block page, show you what's up with that page. If you want to stop at any time and try out the things, you can just click exit tutorial and go to that website. All right. Any questions?